Hi everyone! Today I'm going to show you how to evaluate limits at a point when you have square roots in them. The first strategy I'll show is how you can use a difference of two squares to simplify the problem. In the second problem, I'll show you how you can multiply by a giant one. The first thing you want to try when you evaluate a limit is you want to see if you can plug this in. Now, when I plug 16 in, I get 16 minus 16 on the denominator, and that equals 0. So that tells me I'm going to have to manipulate this using some sort of algebra. In this problem, I'm going to show you how you can simplify this by writing the denominator as a difference of two squares. So I'm going to leave the numerator the same, and I am going to rewrite the denominator like this. To get x, we can multiply the square root of x times the square root of x. And to get 16, I can multiply 4 times 4. And to make sure that we don't get a middle term with the square root of x in it, we are going to put a plus and a minus. Here, we look for a 1. The way things look right now, we can't make any 1s. We see a 4 and a negative square root of x, and here I see a square root of x and a negative 4, which is exactly opposite of this. So what I'm going to do is factor a negative 1 out of the top. So I'm going to pull out a negative. This 4 will become a negative 4, and this square root of x will become positive. It used to have this negative in front. And I'm just going to rewrite what I have on the bottom. So the square root of x plus 4 times the square root of x minus 4. And now what we have is a square root of x and a square root of x and a minus 4 and a minus 4. And now these are the same term. So I can make a 1 here. And what I'm left with on the top is negative 1 over the square root of x plus 4. Now I have the flexibility of putting this 16 in here, because the square root of 16 is 4, and a 4 plus 4 is not a 0 on the denominator, it's 8. So the limit as x approaches 16 for this is negative 1/8. The first thing I'm going to do to evaluate this limit is I'm going to factor the bottom to see what it looks like. So both of these terms have a 2 in common. So I'm going to factor that out. So I'll be left with a 9 minus x. All right, so what can I do from here? In the last problem, I rewrote the part that looked like this as a difference of two squares. I'm going to give us a different strategy in this one. I am going to multiply by the conjugate of square root of x minus 3. Its conjugate is square root of x plus 3. Now we can't just multiply by this. We have to multiply by a 1. And so if I multiply by this, then we're multiplying by a 1. So what do I have here? Well, I have square root of x times square root of x, which is x. Square root of x times 3, which is 3 square roots of x. Negative 3 times square root of x, which is negative 3 square roots of x. And negative 3 times 3, which is negative 9. These terms will cancel. So on the top, I'm just left with x minus 9. I'm going to quick clean that up. On the bottom, I have 2. I'm going to rewrite this so the x's first, negative x plus 9. And then I have square root of x plus 3. Again, these things don't match. And I want to make a 1 here because when I plug in 9, I get that 0 on the bottom. And I can't evaluate the limit when there's a 0 on the bottom. So again, I'm going to factor out a 1 from the top. So I have negative, and I'm left with negative x plus 9. And here we're seeing that 1. So I have negative 1 over 2 times the quantity square root of x plus 3. Now, since this part's gone, that's the part that would make it 0, I can plug in the 9. So I have negative 1 over 2 times the square root of 9 plus 3. I'm going to come up here, running out of space. So I have negative 1 over 2 times 3 plus 3. So I have negative 1 over 2 times 6, negative 1 over 12.